What exactly is a black hole? Imagine a place in space where gravity is so powerful, not even light can escape. That's a black hole, a cosmic vacuum cleaner, but way more mysterious. They're not just empty holes, but regions where matter has been squeezed into an unimaginably tiny space. Because light can't get out, black holes are invisible against the backdrop of stars. But trust me, they're out there, bending the universe in wild ways. So how do these monsters form? Most black holes start life as massive stars. Think 20 times the mass of our sun or more. When these giants burn through their fuel, they explode in a supernova. What's left behind? Sometimes a core so heavy it collapses under its own gravity, shrinking until it becomes a black hole. That's a stellar black hole. But there are even bigger beasts, supermassive black holes. These sit at the centers of galaxies, including our own Milky Way. They can be millions of times heavier than the sun, even billions of times heavier than the sun. No one's entirely sure how they form. Maybe they grew by swallowing stars and gas or by merging with other black holes. Then there are intermediate black holes, somewhere in between, and even primordial black holes, tiny, ancient, and still just a theory. Now let's break down the anatomy of a black hole. At the heart is the singularity, a point where all the mass is crammed together and the laws of physics as we know them just stop making sense. Surrounding that is the event horizon, the point of no return. If you cross it, you're not coming back. Outside the event horizon, you'll often find an accretion disk, a swirling, glowing ring of gas and dust spiraling in. That's actually how we spot black holes, because the disk shines bright in X-rays. There's also the photon sphere, where gravity is so intense, light itself can orbit the black hole. And sometimes, black holes shoot out powerful jets of energy and matter thanks to magnetic forces in the accretion disk. But what happens if you get too close? Einstein's theory of general relativity says black holes curve space and time to the extreme. Time actually slows down near a black hole, a phenomenon called time dilation. And if you fall in, you'd experience something called spaghettification, being stretched into a long, thin noodle by tidal forces. Not a great way to go. So if black holes are invisible, how do scientists even know they're there? They look for stars orbiting around an unseen mass, or for the intense X-rays coming from accretion disks. When black holes collide, they send out gravitational waves, ripples in space-time that we can now detect with observatories like LIGO and Virgo. And in 2019, the Event Horizon Telescope gave us the first ever image of a black hole in galaxy M87, a blurry ring of fire around a shadow. Black holes are still one of the universe's greatest mysteries. They challenge everything we know about physics and push the limits of our imagination. And the more we learn, the stranger and more fascinating they become.